So hello everyone. So our today's Leetcode question is 2976, that is minimum cost to convert string. So here we are given two strings, source and target, and we have to convert our source string to target string, and both these strings are in lowercase English letters, and with these we are also given three arrays, two characters arrays, original and changed, and one integer array, cost array. So what these arrays are showing is like cost of I represents the cost of changing character original of I to character changed of I, and we have to return the minimum cost to convert our string source to the string target, and if it is not possible to convert, then we have to return -1. So if you'll see the constraints, then our source length and target length is up to 10 to the power 5, and these arrays cost length, original length, these arrays can be up to 2 to the power 1000, sorry, wrong, 2000, and cost of I can be up to 10 to the power 6. So if you'll see an example, we are given source as ABCD and target as ACBE, and the original array is ABCCED and change array. So we what these three arrays are showing. So if we change from A to B, then the cost will be 2, right? If we change from B to C, then the cost will be 5. So if we see that there are two type of conversions that we can do. So one is direct conversion, that is directly given to us. So A to B direct conversion, B to C direct conversion, C to B. But suppose if I say you that I have to convert from A to C, so there is no direct conversion from A to C. So what can I do in that case? In that case, I'll be taking A to B and then B to C, right? A to B and then B to C. So the total cost will be 2 plus 5, 7. So this other conversion is using via some other intermediate characters, and also it is not necessary that our direct change is always having the minimum cost. So how we will be handling these intermediate conversions and all? So what can we do is, using our original array, change array and cost, what we can do is we can construct a graph that will show us that we can convert from one character to other, and the edge weight will show the cost, right? So see here, if I have to convert from A to C, so means I can go to A to B and then B to C, and then the shortest path length between A to C will be the minimum cost to convert A to C. Then the next question is, how can we find the shortest path between two characters in the graph, or between two nodes in the graph? So either we can use Dijkstra algorithm between each pair, or what we can use is Floyd Warshall algorithm, right? So Dijkstra algorithm, so what it does is it gives us the shortest path between a source node and a destination node. I have already explained it in a previous video, so please watch that out. I'll mention the video above. And so if you'll see the code using Dijkstra algorithm, so what we have done is, initially we have made a graph using original array, changed array and cost, right? After making the graph, what we have done is, for every source node we have applied the Dijkstra. So this is the code of the Dijkstra. So we applied a Dijkstra algorithm, and once we get all the shortest distances, then we have iterated over the source array. So if the characters in the source array and target array is same, then we won't be doing anything else. We will find the minimum distance or minimum cost to convert uh, character in source array to character in target array. So if the minimum distance or minimum cost is greater than equal to infinite, that means there is no direct way or no direct connection between those two characters, so we can't convert those two characters. In that case, we will be returning -1, else we will be updating our answer, and at the end we will be returning our answer. The next way we can find the minimum distances between all the pairs is using Floyd Warshall. So what Floyd Warshall does is, so suppose let's take an example. If you have to go from Delhi to Mumbai, so there is a direct path, and there are some intermediate other paths which go via other cities. So Floyd Warshall checks whether the distance of going directly is minimum, or if we go using or via some other cities, so it will take those distances. Suppose direct distance Delhi to Mumbai, or Delhi to Pune, and then Pune to Mumbai, and then some of these. So which distance is minimum? So Floyd Warshall checks all these possibilities, and at the end it will return as the shortest distance between uh, two nodes in the graph. And this way we'll be doing for all intermediate nodes and for every pair. So the time complexity is big of v cube. So see, here we have taken a graph. So the initial distance matrix infinite is representing that there is no connection between those two nodes, right? So suppose first we will try via node 0, because we will be trying via every node. So suppose I have to go from A to B via C. What does that means? That first I'll go from A to C, and then C to B, and then I'll add the total cost, and then check whether the cost that I get now is minimum or the direct cost is minimum, right? And one more thing, the node which we update now, those rows and columns won't be changing, because going from A to B via suppose A, then A to A. So A to A means the distance is 0. So those rows and columns won't be updating. So suppose here in this graph we have to go from 3 via 0 to 1. We have go from 3 to 1 via 0. So direct distance is 5. And if we go from 3 to 0, the distance is 3, and then 0 to 1 5. So here both the ways the distance is same only, so we want to be updating it, right? Then we take the, so see, distance of 3 comma 0 plus distance of 0 comma 1, that is 3 plus 2 equal to 5, and the direct distance is also 5. So minimum of 5 comma 5 is 5. So this way we will be calculating for uh, every pair and via every node. So at the end what we get is we get our all shortest path between all the possible pairs. So this is the code for this Floyd Warshall. So here our wire nodes can be up from A to Z, so means 0 to 26, A to Z, and then we will be forming every possible pairs, and then distance from I pair to J, I to node J is equal to direct distance we take, and we take distance via any node, and then we take minimum of those two values. So if you'll see the final code using Floyd Warshall algorithm, so we have make a distance matrix, and this loop is making distance from every node has distance 0 to itself, right? So this is simulating that, and then we make the graph using original, change, and cost, right? And then we have here we have used Floyd Warshall algorithm, that is our k is denoting the nodes via nodes, that we can go via this node, and then using I and j we will be finding pair, and distance of I comma j is equal to minimum of direct distance or the distance that we go via going some other node. And once we get all the shortest distances, then we will be using a loop on the source array, and then we'll checking that whether we have to convert or not. And if it like if we have to convert, then we check whether that there is a connection between these two characters or not. If no connection, then return -1, that means we can't convert, else we'll be updating our answer and return the answer in the end. I hope you get this solution. If you like it, please make sure to like, share, and subscribe the channel. Thank you.